In this video, we're going to take a look at the classification of carbohydrates. And carbohydrates, as the name implies, is probably going to have something to do with carbon and hydrates, water, H2O. And if you made that connection, then you'd be right. Carbohydrates does have something to do with carbon and water. Now, carbohydrates are really just what we think of as sugars. And there's multiple different types of sugars. We're going to learn more about those coming up. And polymers of sugars. Sugars and polymers of sugars make up carbohydrates. And the carbohydrates generally have a formula of carbon, C6H12O6. And if we kind of break this down or kind of get the lowest common denominator out of all of this, you'll see that we end up here with carbon and H2O 2 here, or excuse me, N as well, like this, okay? And so this is just like the lowest common denominator, and you can put some number in here. It could be 1, 2, 3. It could be the same number over here. Sometimes people write it a little bit differently and go CnH2nOn. But anyway, carbohydrates generally have this formula, and this is how we got the name. Now, as it turns out, we found that not all carbohydrates do have this formula, but the name still stuck. Okay, so this is kind of a generalization, but it doesn't always apply in every circumstance. Now, as far as carbohydrates go, we have monosaccharides. Monosaccharides. And mono means one, and saccharides, that is Latin for sugar. So saccharide is just Latin for sugar. And so monosaccharides are monomers of sugars. Monomers are a monomer unit. I'm just going to say monomer unit here. Monomer unit. And so mono, again, means one, and monomer means is just like one piece of a larger thing. And so what we're going to find out is oftentimes we take single individual carbohydrates or sugars, and then we connect them together to make long chains of sugars. Now, some of these monomers that maybe you've heard of, maybe you haven't, I don't know, glucose, fructose, and galactose. All of these end in OSE, which is if you've taken a biology course, you might recognize that's the ending for a sugar. Glucose, this is found in your blood supply. If you're diabetic, you're probably monitoring your glucose levels. This is also the only energy source that the brain relies on. Fructose is found in fruit. So these are just monomers of carbohydrates that we could string together and make larger molecules. And we'll take a look at the actual structures of these in a later video. Now, disaccharides. Disaccharides, di meaning two, saccharides meaning sugar. So these are two monomers joined together. And a couple of examples of this might be sucrose, and maltose. And you might recognize sucrose. Sucrose is what we think of as table sugar, and sucrose is two monomers joined together. Those two monomers is or are fructose and glucose. And again, we'll take a look at these structures later on. So two different monomers joining together to form the disaccharide sucrose. And maltose, the two monomers are glucose and glucose. So two monomers join together, two glucose monomers join together to form the disaccharide maltose. Okay, now what does it look like when we join these things together? Well, I'm going to do it diagrammatically. This is not perfect, so it's just kind of a simplification. The kind of linkages that join these monomers together. I'm going to draw just kind of a basic outline here of a monomer, okay, like this, and we'll have an OH like this, and then we're going to go CH2OH like this, up here like this, OH and H like that. Okay, and I'm going to combine this here. It's like a cyclohexane, but then we have an oxygen here, so it's kind of like maybe like a cycloether sort of thing. But anyway, there's 5 carbons, 1, 2, 3, 4, 5, and then a 6th one up here. Okay, so in a ring structure with the oxygen here. And then over here, off of this carbon, we've got a hydroxyl group coming down. And I'm going to draw another one here, and I'm going to go like this and like that, trying to draw like this, CH2OH, like this, OH, and then H like that. Okay, so what's going to happen here? We have monomer and we have monomer, okay? Monomer, okay? Or monosaccharide, okay? Individual carbohydrates here. And if I join these two together, you might recognize here, okay, I've seen this before. We have a hydroxyl group here, we have a hydroxyl group here. I bet what we could do is take like the OH off of one of these and maybe the hydrogen off of one of these over here, like this, and then we would remove, we take out of these here water, okay, HOH, okay? So we would bring these two together by removing water, and then we'd be left with just an oxygen atom there. So over here, what we're left then is going to be our disaccharide, or our two monomers joining together. And so when we draw these here together, like this, now like this here, CH2OH, like this, and then like this, okay, up and then over, and then down, and then down like this, CH2OH, like that. Okay, and so what I've done here now is I've joined them together into a disaccharide over here. Disaccharide. And we see here that there's an oxygen atom linking them together. Now this is just kind of diagrammatic here. There'd be other things attached. This is just kind of a rough outline for right now. We'll get into the structures in a little bit. Now, this is one way that we can join them together, but there's also another way that we can join them together. So we're going to take a look just briefly at how these are linked together. Now, the way that this is joined together has a special name for it, and I'm going to give you an example of the other way it can be joined together. So in this way, we have that oxygen atom coming down, and if I were to do it another way, draw it another way, we might have it going like this, where we have oxygen atom in here, oxygen atom, two, H like this, okay, and then up, and then oxygen, okay, and then like this here. Okay, now, two different ways of joining a disaccharide together. One is with the oxygen atom coming down like this. The other is with the oxygen atom coming up like this here. So if it's coming down like this is what we call an alpha linkage. It's with this coming down like this. And if it's going up like this is called a beta linkage. Beta linkage. Alpha and beta. And examples of this. This here beta linkage would be like cellulose. And over here it might be starch. Starch. Okay, and if we think of like starches, starch might be how plants store energy, such as in like potatoes. Okay, so that would be a starch, and then cellulose. This is in plant cell walls, so this is more for structure. So this is for energy storage. This is for structure. Now, as humans, we have the enzymes to break this down. We don't have the enzymes for breaking this down. And I've often wondered, okay, so like cellulose, what has a lot of cellulose in it? Grass, hay has cellulose in it. And you could eat it, but you wouldn't get any nutritional value out of it because it'll just be fiber. You don't have the enzymes for breaking it down. And but things eat this. I think like cows and horses and such, they eat cellulose. And they have bacteria and such in their gut that break this down. But I've wondered, you know, starches, you chew on those, they taste sweet, okay? Those carbohydrates taste sweet. Grass doesn't. Do you suppose grass tastes sweet to a cow? I don't know. This is the stuff that keeps me up at night. So something that's kind of curious is if you take a look at the ingredient list of, say, a diet bread, you might see cellulose listed. And based off of what you know now, it might be a bit of a head scratcher. Why would you add cellulose to the ingredients for your bread? And the answer is that we can't, as humans, we don't digest cellulose. And so what cellulose does is it adds bulk, it adds weight, it basically adds fiber to the bread, but not calories. And so it's basically just adding sawdust to your bread as an ingredient. Huh, the more you know. All right, now that's disaccharides, okay, just taking two monomers and joining them together. A polysaccharide would be taking many of these units and joining them together. Many units and joining them together would be a polysaccharide. And then we have something called an oligosaccharide, and that's kind of in between. An oligosaccharide is between like disaccharides or trisaccharides and polysaccharides. So depending on who you ask, it's between like 3 and 10 monomer units would be an oligosaccharide, and then a polysaccharide might be more than 10, but that's a little fuzzy on that. It's not worth fighting over anyway. All right, so that's the classification of carbohydrates.